Welcome to my channel, Jahangir's Science School. Today I am going to solve IAL AS Physics Unit 1 May-June 2022 question. This is part 3 video. Question number 15. A Galilean thermometer consists of a closed glass cylinder containing a liquid. In the liquid, there are several identical sealed glass bulbs as shown. Attached to each bulb is a metal disc labeled with a temperature. Each disc has a different mass. Look at the diagram here. Metal disc and liquid, glass cylinder, glass bulb. As the temperature increases, the density of the liquid decreases. This can cause the bulb to move within the liquid. Explain why a particular bulb will float until the temperature liquid exceeds a certain value. So upthrust force on a bulb is equal to weight of the liquid displaced, weight of the liquid displaced by the bulb. So upthrust is the amount of upward force experienced by a solid object when it is submerged inside a liquid or gas. So Archimedes discovered that this amount of upthrust force on a solid object is equal to the weight of the liquid or gas displaced by the object. Second, when upthrust force equals or exceeds weight of the bulb, then bulb floats. So when upthrust force is denoted by U greater than W or equal, then the object will float. Weight of the bulb is constant. Weight of the bulb is constant. Why constant? Because weight of the bulb is the amount of pulling attraction force by our planet Earth towards its center. So weight is constant, weight of the bulb is constant. As the temperature increases, increases, the weight of the displaced liquid decreases. The weight of the displaced liquid liquid decreases. So uh, temp so as the temperature increases, upthrust force upthrust force on the bulb decreases. So there is a resultant upward force and bulb and the bulb will sink. Bulb will sink. As the temperature increases, upthrust force on the bulb decreases. So resultant force becomes downwards. Resultant downwards force, and the bulb will sink because now upthrust force is less than to the weight. So weight is greater. So bulb will sink. So when weight of the object is greater than upthrust force, that means upward force. That means downwards resultant force. Then it will sink. A student is flying a kite. The kite is held in equilibrium by a straight action. The weight of the kite is 24 Newton and the wind exerts a force of 70 Newton at an angle 43 degree to the vertical as shown in the below. This is the diagram. Weight of the kite is 24 Newton and 70 Newton is the force exerted by the wind. Determine the magnitude of the tension in the string by using the scaled vector diagram. First we have to fix the scale 1 Newton, say 1 Newton equal to 1 millimeter. So to solve this question we need a scale. So first 24 Newton, so 24 millimeter, that means 24 Newton, and there is a force exerted by wind is 70 Newton. So we need 70 millimeter length line, and 24 millimeter. So here 24 Newton is the weight of the kite. So tension force of the spring will be, according to the vector triangle rule, if two adjacent arms represent two vectors in same order, then the third arm will represent the resultant force in the opposite way. then it will be 55 millimeters. So resultant force, so tension force equal to 55 Newton. So answer is 55 Newton. It is the application of the vector triangle rule. Vector addition triangle rule. Or law of triangle rule. Now question number B. The student wants to determine the tension T in the string. She attached a mass holder to the string. The student adds known masses to the mass holder until the kite is in equilibrium and part of the string becomes horizontal, as shown. The student takes a photograph of the arrangement. Describe how the student can use the photograph to determine T. First we have to measure the angle, theta with vertical line. This one is the vertical. So first we have to measure the angle of string to the vertical line, by using protractor. Then we have to measure the weight of the mass holder. Calculate the weight of the mass holder and mass using the formula W equals to M into G. M is the mass and G is the gravitational field strength. Vertical component T is equal to the vertical component of T is equal to W, weight. So this T force produces angle T, so T cos theta, vertical component is T cos theta, and weight W. So T cos theta equal to W. Then we can calculate T, W divided by cos theta easily. So remember, tension force produces theta angle with the vertical line. This one is the vertical line. We know that the part which produces angle, tension T produces theta angle with the vertical line. That's why it is T cos theta, and opposite force W, weight, acts downwards. So that's why T cos theta equal to W. Remember this technique. Now question number 17. This is my favorite topic, momentum. This is the question. This question is related with momentum. This is the bumper car. The diagram shows two bumper cars, P and Q, at an amusement park. So diagram shows two bumper, P and Q, at an amusement park. Q was stationary. So this one is stationary, Q1 is stationary, and P was moving at a speed 2.10 meter per second towards Q. P collided with Q. After the collision, P and Q moved off in the same direction. P moved with the speed 1.15 meter per second. Q moved with the speed 1.57 meter per second. Show that the total mass of Q was 150 kg. Total mass of P is 250 kg. So, in this question, show that the total mass. So we know momentum equal to mass into velocity. So momentum of the P bumper car is 250 kg into 2.10 meter per second. This is the initial momentum. That means total momentum before collision, because Q was at rest. So in any system, if no external force is applied except collision, then total momentum before collision is equal to the total momentum after collision. So total momentum before collision was 250 kg into 2.10 equal to total momentum after collision 250 kg into 1.15 meter per second is the momentum after collision, plus mass of the Q bumper car. Say consider mass of the Q is M. So M into 1.57 meter per second. So M equal to, so here total momentum before collision is 237.5 kg meter per second divided 1.157. So 151.3 kg is the mass of the Q bumper car. Q bumper car is 151.3. So remember, in any type collision, total momentum before collision is equal to the total momentum after collision. So before only P bumper car was in motion. So total momentum before 250 kg into 2.10 meter per second. 1 meter per second. On the other hand, after collision, bumper car A 250 kg and moves with a final velocity 1.15 meter per second. We have to find out the mass of the bumper car Q. So let's consider the mass B, mass of the bumper car Q B M. So we have to find out the mass M. So mass M into 1.57 meter per second is the final velocity of the bumper car Q. So MQ equal to 237.5 kg meter per second divided by 157 meter per second. So 151.3 kg. State one assumption you made in your calculation. So we have to consider no external force, no external forces acted on either car during the collision. Now the collision lasted total time 1.57 seconds. Calculate the average force on Q during the collision. So average force, we know force equal to change in momentum by T. So we have to find out the horizontal force on Q. So change in momentum. Mass is 151.3 kg and change in velocity here 1.16 meter per 1. Look at the information here. Q was stationary and it moves with a velocity 1.157 is 57 meter per second divided by 1.35 second. So after calculation we get 1.76 10 to the power 2 Newton. So we know momentum, so force equal to change in momentum divided by time taken. So m v minus u by t. So here final velocity 1.57 and initially q was 0, so mass 151.3 into 1.57 minus 0 divided by 1.35 second. So this is the answer. Now a last question of the question number 17b. Explain why P decelerates during the collision. Your answer should make reference to the Newton's laws of motion. So P exerts a force on Q. So Q also exert a force
on Q, on P. Because according to the Newton's third law of motion, every action has an equal and opposite reaction force. Because according to the Newton's third law of motion, every action force has an equal and opposite reaction force. Because due to forces are equal and opposite direction, resultant force on P opposite of motion, so it decelerates. We know when the direction of the resultant force is opposite to the motion of the object, then the object will decelerate. So that's why P decelerate during the collision. Now question number 18. Question number 18. A golfer hit a golf ball into the air at a speed 52 meter per second at an angle of 41 degree to the horizontal as shown. The ball landed on the ground near a hole. The ground was 11 meter higher than the starting point of the ball. Show the vertical component of the ball's initial velocity was about 30 meter per second. So we know vertical component of initial velocity uy equal to u sine theta. Here initial velocity is 52 sine 41 degree. So correct answer is 34.1 meter per second. So the vertical component of the initial velocity was 30 meter per second. About 30 meter per second. Now question number B. Show that the time taken by the ball to reach the ground was about 7 seconds. You should ignore the effect of air resistance. Show that the time taken the ball to reach the ground was, okay, we know Vy equal to Uy minus Gt. So at maximum height Vy equal to 0. So Uy minus Gt. So T equal to Uy by G. This is the time taken to reach the maximum height, but we have to find out the time taken by the ball to reach the ground. So we need this time. So total time of flight. So t equals to twice t, because time taken to reach the maximum height and time to fall from the maximum height to the ground is same. That's why twice t. So t 2 uy by g. So here 2 into 34.1 divided by g, 9.81. So correct answer is 6.62 second. Now question number C. Question number C. Look at the question first. The hole is a horizontal distance 250 meter from the starting point of the ball as shown. Deduce whether the ball landed within 5 meter of the hole. You should ignore the effect of air rest. So we know horizontal distance equal to ux into t. Ux equal to u cos theta into, we should use capital T, time of flight. So u here u 39.2 cos 41 degree into capital T 6.62 second. So distance is total horizontal distance 260 meter. Distance required distance required to 45 meter to 255 meter. So 260 meter is greater than 255 meter. So no. Now question number 19. A falling sphere viscometer is a device used to determine the viscosity of a liquid. A sphere falls through a cylinder containing a liquid and the terminal velocity of the sphere is measured. State why the temperature of the liquid should not increase during the measurement. Because the viscosity depends on the temperature. Viscosity decreases with temperature. This one is a control variable in this experiment. We have to fixed or constant the temperature. That's why it is a control variable. So temperature is a control variable. Otherwise, viscosity varies with temperature. Now, a scientist measured the terminal velocity of an aluminum sphere as it fell through the glycerol. Show that the weight of the sphere is about 4.8 into 10 to the power minus 3 Newton. Density of the aluminum given 2.70 10 to the power 3 kg per meter cube, and diameter of the sphere 7 into 10 to the power minus 3 meter. So a scientist measured the vertical velocity of the aluminum sphere is filled. Show that the weight of the sphere is we know volume of the sphere is 4 by 3 pi r cube is the formula, and density equal to mass divided by volume, and we use W equals to m into g. M into g. So mass equal to volume into density into g. So volume 4 by 3 pi r cube, but in our question it is diameter, so d by 2 cube into density given and g. So 4 by 3 pi 3.14, and diameter is given, so diameter is 7 into 10 to the power minus 3 meter divided by 2 then cube, and density of the aluminum is 2.70 10 to the power 3, and 9.81 is the acceleration due to gravity, that means gravitational field strength. Then after calculation we get 4.76 into 10 to the power minus 3 Newton is the weight. So weight of the sphere is 4.76 into 10 to the power minus 3. So we can write 4.8 10 to the power minus 3 Newton shown. Now question number B2. The terminal velocity of the sphere was 4.05 10 to the power minus 2 meter per second. Deduce the whether Stokes law applied to falling sphere. So according to the Stokes law, drag force, viscous drag force equal to 6 pi eta RV. This is the Stokes law. Then so terminal velocity, when terminal velocity is achieved, so W equals to upthrust plus drag force. So drag force equal to W minus upthrust force. Weight is 4.76 into 10 to the power minus 3 Newton. On the other hand, drag force we can calculate drag force by using this formula, drag force 6 pi 3.14 eta coefficient of viscosity 0.95 into 6 pi eta RV. R is the 7.0 10 to the power. Here diameter was given. Diameter is 7 into 10 to the power minus 3. 7 to 10 to the power minus 3 divided by 2. RV. V is the velocity. So terminal velocity is 4.05 10 to the power minus 2. So drag force is after calculation 2.2 10 to the power minus 3 Newton. So subtract this value from 2.2 10 to the power minus 3 Newton. So upthrust force is 2.54 10 to the power minus 3 Newton. So upthrust equal to weight of the displaced fluid. Upthrust equal to weight of the displaced fluid. Displaced fluid. So V rho G. So 2.22 10 to the power minus 3. And drag force is 2.54 54 10 to the power 3 Newton. So drag force equal to, so obeys Stokes law obeyed. So Stokes law obeyed. State one condition that must be meet for Stokes law to apply. So Stokes law only applicable when the liquid is in laminar flow. Laminar flow. What is the meaning of laminar flow? When the direction of movement of the all fluid is same with the direction of the movement of the fluid flow, and they move with steady speed, then we can apply Stokes law. So there must be low speed, and now question number C. A scientist used the viscometer to measure the viscosity of blood. The viscosity of the blood is typically in the range 4 into 10 to the power minus 3 Pascal second to 4 into 10 to the power minus 3 Pascal second. Explain why the scientist should use an aluminum sphere with a much smaller diameter than the sphere used with glycerol. Do not include calculation in your answer. Viscosity. So viscosity of blood is much lower. So drag will be lower. So drag force will be lower for a given velocity. And reducing diameter gives less weight, because so forces balance at lower speed. So forces balanced at lower speed. Because laminar flow needs low speed. Thank you for watching my video. If you like this video, then subscribe my channel